Like, why couldn't we use a torpedo?
Well, the torpedo will fall back off of an acid. So depending on the conditions of what you're going to react the next thing in, if it becomes acidic, the torpedo will fall off before you can actually do the reaction. Or as you're doing the reaction, there'll be competition. Good.
This is the only mechanism for these job.
So far, I think so, yeah.
And the other equations, like the Williams and the policy, is that on the given?
It should be on the reaction sheet, yeah. The only thing with, let me see what it says on the reaction sheet. Yeah, the only thing is that it's listed, let's see, a little bit separate, a little bit differently, or separately on here. So the Williamson uses, you know, the alkoxide and then alkyl halide. That's not really on there because it's not really a, it's not reagent. It depends on the reagent. The alkoxide is whatever it is. So it's just a substitution reaction, really. So that's not really a reagent set per se. But I do have the imidazole DMF, which would be used if you're using the silyl ether protection group, and I have the TBAF on there as the deep protection. So I think, yeah, there's not a heck of a lot of reagents really, because we've done most of these before. There's somewhere else on the reagent sheet. So that's where it's going to get a little bit, I don't know, maybe a little bit difficult when you're looking at these reagent sheets now. If we repeat the reagents, I'm not going to write them again in this new section. So, like phosphorus tribromide, thiamine chloride, they're over here from a few chapters ago, but it's still applicable to today's lesson. Or I guess it was last lesson 7. Okay, and again, as usual, there's some practice problems there to take a look at if you want to just keep practice these type of substitution reactions. The mechanism, drawing it over again. The one thing I'll say is just always pay attention to, when you look at the two reactants given to you, think about which one is more nucleophilic, which one's more electrophilic, and that'll tell you, that'll drive you to which way you should, you know, take the reaction. Because we've talked about making an ether just by using acid, and we talked about breaking an ether by using acid. So it just depends on what you have as a starting material. Well, we use making it with an acid and an alcohol. Here we're using an ether with an acid to make an alcohol, or to make an alkyl halide. So we can kind of go back and forth depending on what you have as a reagent in the reactants and which one is a stronger nucleophile, electrophile. So just pay attention to that. Remember, acids always give up the proton, and the alcohol is going to take it in that case. Okay? Any other questions? Wasn't too bad? Got both lessons in plenty of time. All right, well, have a good snow day tomorrow. I want to figure out how to download it.